In this video, we'll review the AAPM TG270-pQC test pattern, which is included as part of the test patterns in the iQC version 2.2 of the PAX display software. The AAPM TG270-pQC test pattern is a detailed QC pattern for physicists and other advanced users. It has the same gray levels as the AAPM TG270-SQC test pattern, but with more contrasts and frequencies. On the next few slides, we'll go through the details of the many features of this pattern. First, let's start with the central region. The central column of the test pattern is a series of luminance patches that can be used for an 18-point luminance response measurement. These are equally spaced gray levels, and for an 8-bit display, that means it'll be every 15 gray levels. These are the same gray levels that are used for the AAPM TG270-SQC test pattern and the original TG18LN series of test patterns. If you have zooming and panning capabilities, this region of the pattern could be used to make a quantitative luminance response measurement. The next region of the test pattern we'll look at are the series of line pairs that are displayed to either side of that central column. Let's take the next slide to look at one section of these line pairs. The line pairs are low contrast bar patterns, which are displayed at 2 different contrasts and 4 different frequencies. On the right side of the central column, they're vertically oriented, while on the left side of the central column, they're horizontally oriented. The way to use this section of the test pattern is to scan your eye up and down vertically along the test pattern at a given contrast and frequency, and assuming DICOM GSDF conformance, the appearance of that contrast and frequency should appear roughly constant throughout the grade level response. Here you can see the details of the structure of these, with 4, 6, 12, and 18 pixels per line pair, and then again 4, 6, 12, and 18 pixels per line pair at the 2 different contrast levels. 2 grade levels on the inside, 8 grade levels on the outside. As I mentioned on the previous slide, if you scan your eye up and down at a given frequency and contrast, in this case 4 pixels per line pair at the grade level contrast of 8, the appearance of those gray bars throughout the entire response should appear roughly constant. Next, let's look at the top and bottom sections of the pattern. At the top and bottom sections of the pattern, high contrast squares at 3 different frequencies and 2 different orientations are displayed. Along the top of the pattern, you can see that you have gray levels 0 and 128. And then at the bottom of the pattern, you have gray levels 128 and 255. The frequencies of the boxes are displayed here at 2, 4, and 6 pixels per line pair. This region of the pattern can be used to verify pixel mapping from your graphics card and operating system. If you display at a non-native resolution for the display, you'll have an interference pattern and you won't have distinct, bright, dark lines along the top and bottom of the pattern. Next, let's look at the right and left side of the pattern where a grayscale ramp and a modulating sinusoid is displayed. The continuous grayscale ramp with that modulating sinusoid function through the center allows you to verify smooth transition throughout the entire grayscale. The left side of the pattern's grayscale goes from black at the top to white at the bottom, while that's switched on the right side with white at the top and black at the bottom. If you scan your eye vertically up and down through the pattern, the appearance of that modulating sinusoid should appear roughly constant throughout the entire grayscale. In addition, any bit depth issues or scalloping issues will be visible if a single gray level is miscalibrated or if you're using the incorrect bit depth settings for your graphics card and display.